All right, guys, welcome to 7.4. Today we are verifying trig identities. So the goal is to work with the more complicated side and try to simplify it so it actually equals the right-hand side. Okay, so the good news is you know the answer. The bad news is there's a lot of ways to get there sometimes, and you have to strategically pick the right one. So I think I'm going to use the negative angle identities here. So remember, sine of negative theta is actually equal to negative sine of theta, and then note that it is squared. All right, and then minus. And then we know that cosine of negative theta is actually still just cosine of theta, and we also want its square. All right, so that's what I'm going to do to the top. And then on the bottom, same thing. Sine of negative theta is negative sine theta minus, and cosine of negative theta is just cosine of theta. Okay, on to the next step. So we can, if you square negative sine of theta, you get sine squared theta. If you square cosine theta, you get cosine squared theta. And in the denominator, I'm just going to leave it the same. Negative sine theta minus cosine theta. All right, now I'm going to come up here. Okay, so nothing crazy yet. This is almost that identity. If you sin, it'll cost you one, but it would have had to be a plus sign. So since it's a minus sign, though, we can factor it. It's actually the difference of two squares. So sine theta minus cosine theta and sine theta plus cosine theta. Okay, and then in the denominator, instead of just writing again, I'm going to try pulling out a negative. And if you pull out a negative sign, we're left with sine theta plus cosine theta. And the reason I did that is because now I see some common factors that can cancel. Sine plus cosine and sine plus cosine, they cancel. And then if I just distribute the negative sign into these, I do get what I want. A negative cosine is a positive cosine theta, and then a minus sine theta. Okay, and then once you get what you want, I just put a check mark. Done. So you really got to look ahead and see what you want and then just kind of make it happen with no illegal algebra. Okay, number 2. Now, some people turn tangent and cotangent into sines and cosines, but since what we want is also a form of tan, I'm going to try to leave everything in terms of tan and see if I can get it that way. Sometimes you just try something and fail and try a different way. So to me, 1 plus tan is already pretty simplified. So I'm just going to leave it alone. But in the denominator, how can I write cotangent in terms of tangent? Well, cotangent is 1 over tan. Okay, so I'm just going to change that. And then as I look in the denominator, I'm going to want to get a common denominator. Okay, so the top is going to stay the same, 1 plus tan of u. But in the denominator, if I get a common denominator, it's going to be tan of u plus 1 over tan of u. And I'm going to make this one thicker so you remember that's the big fraction. Okay, and then you guys know dividing by a fraction is the same as multiplying by its reciprocal. So now we have the 1 plus tan u times the reciprocal, tan u over tan u plus 1. Right? I just flipped this and multiplied. And then that's lovely because look, 1 plus tan u and 1 plus tan u cancel. And notice we're left with just tangent of u. And that's what we wanted, so we are donezo. I love these. I don't know about you guys. All right, number 3. This one we Should we try, let's see, everything in terms of sine and cosine. So I'm thinking maybe we just try to get a common denominator, put them together and see what happens. So this piece needs a common denominator of sine. So I'm going to multiply top and bottom by sine. And this here needs a common denominator. It's missing the 1 plus cos. So I'm going to multiply it into the top and bottom. Okay, so you guys know how to get common denominators. So on top now, we have sine squared theta. And on bottom, if we distribute, we have sine. Actually, sometimes you want to distribute, sometimes you don't. Just in case, I'm going to leave this undistributed, but we might have to later. Okay, so keep in mind, you might want to distribute later. All right, now this guy, let's see, if I distribute, we're going to have to FOIL. So 1 plus cos times 1 plus cos is 1 plus 2 cosine theta plus cosine squared theta. And then on the bottom, again, I'm just going to leave it because I'm not sure if distributing is going to be helpful yet. So I'm just going to leave it as sine times 1 plus cos. Okay, now we have a common denominator. I'm going to slide this up a little bit. We have a common denominator of sine theta times 1 plus cos theta. And now can we just clean up the top? Now look at this. If you sin, it'll cost you 1. Sine squared plus cosine theta, sine squared plus cosine squared is 1. So all of this is really just another 1. And then if we add 1 plus 1, we have 2 plus 2 cosine theta. Okay, I think I'm glad that I did not distribute, because now if we divide out, factor out a 2, we'll be left with 1 plus cosine theta in the numerator. And I am just going to copy down our denominator. And here's what I was talking about. Good thing we didn't distribute, because now 1 plus cos and 1 plus cos cancel. And we're left with 2 over sine. But dividing by sine, it's the reciprocal of cosecant. So actually, we are done. This is 2 cosecant of theta, and that is what we wanted. All right, awesome. Moving on. Let me get my new sheet here. 2 more. You guys are doing great. Keep it up. All right, this guy. Now this one, we've got everything. We've got tangent, cotangent, secant, cosecant. When that happens, sometimes it's best to just convert everything into sines and cosines. Okay, this is kind of like my backup if I can't think of anything else. So tan, we know, is sine over cosine. And then cotangent, we know, is cosine over sine. And then secant, we know, is 1 over cos. And cosecant, we know, is 1 over sine. And now we just have to use legal algebra to clean this up. So on the top, we might need a common denominator. So in the numerator here, if our common denominator is cosine sine, then this one needs a sine, and this one needs a cosine. Again, I'm just assuming you guys know common denominators. So sine times sine will be sine squared v, and cosine times cosine would be cosine squared v. And then, why don't we just clean it up while we're here? If you sin, it'll cost you 1. So this is just 1 over cosine v sine v. Okay, but don't forget, we still have this denominator divided by 1 over, if we put it together, cosine v sine v. Because if you're multiplying, you don't need a common denominator. Oh, well, this is great. What's anything divided by itself? Or if you multiply by the reciprocal, cosine v sine v over 1, you'll see that these cancel and we end up with 1. And that is what we wanted. All right, so that sines and cosines worked out for that one. All right, and then on to this one. Oh, we're already in sines and cosines, but it doesn't really look like there's much to do. So another trick sometimes is to multiply by the conjugate. And you have a choice which side you want to work with. I'm going to work on the right-hand side. Why not? So since I can't really, I can't really see what to do, I'm going to try to multiply, instead of 1 plus sign, I'm going to try 1 minus sign. And that's called multiplying by the conjugate. And I'll show you kind of why that's a good idea on this one. So we can distribute. Sometimes it's not helpful to distribute. So I'm actually going to leave them separate for now, just in case. And if I need to distribute later, I will. And on the bottom, I definitely am going to distribute because I can see it's going to be an identity. So if you FOIL out the bottom, you end up with 1 minus sine squared theta. Because the 1 times 1 is 1, the minus sign and the plus sign cancel, and then the minus sine squared. Okay, great. Let's see what we can do next. Keep in mind where we're headed. This is what we want. So I see part of it here. We just got to figure something out with this. So next, this is really an identity. If you sin, it'll cost you 1. So 1 minus sine squared is actually just cosine squared if you rearrange the identity. And then that's nice because now cosine and cosine squared reduces to, it's gone in the numerator and it's down to a single cosine now in the denominator. So now we are left with 1 minus sine over a single cosine. And that is what we want, so we are done. All right, so by multiplying by the conjugate, we are able to get a squared identity, so we can use one of those Pythagorean identities. And that was really helpful. All right, thanks for watching, guys.